miles of roads, more cars, and more truck traffic than ever before. Most of our personal travel and freight moves over highways. The nation's economy and quality of life depend on the good condition of our roads. Although the demands placed on our highway system have increased, the level of funding for public road construction and maintenance has remained fairly constant. As these trends continue, highway agencies will have to make ever more efficient use of the funds that they have. To enable highway agencies to meet this challenge, Congress created the Strategic Highway Research Program, or SHRP, to achieve rapid progress in highway technology. SHRP is a 5-year, $150 million program administered as a unit of the National Research Council and funded through a set-aside of 0.25% of state-apportioned federal highway aid funds. SHRP is seeking solutions to common but costly problems. Problems like pavement deterioration, bridge corrosion, snow and ice control. The pace of activity since startup in April 1987 has been rapid. By December 1988, SHRP had awarded 64% of its budget for planned research. Most of the other research projects are scheduled to begin in fiscal year 1989. SHRP contracts are awarded on a competitive basis to researchers at universities, private companies, and non-profit organizations. Asphalt, pavement performance, highway operations, and concrete and structures were selected as target areas for SHRP research by expert panels that included representation from state highway agencies, industry, and research organizations. Let's look at the objectives in these areas and the progress that is being made. Asphalt is used on 93% of the paved highways in the United States and accounts for about $10 billion a year in highway expenditures. Most asphalt pavements last about 20 years, but some fail rapidly, and these failures are costly to all involved. High-performance asphalt pavements have the potential to save highway agencies millions each year. The causes of asphalt pavement failures are often difficult to pinpoint. Pavement performance can be affected by oil recovery and asphalt refining processes, by storage, handling, and transportation practices, by pavement mix design and construction procedures, soils, and once in service, exposure to traffic and weather. SHRP's asphalt research will focus on two key products that will improve asphalt performance: performance-oriented binder specifications and accelerated tests of asphalt aggregate mixtures. The composition of the asphalt materials available in the U.S. market is highly variable because the crude oils used in the United States come from hundreds of sources around the world. This variation makes asphalt binder performance particularly difficult to predict. Dozens of different acceptance specifications for asphalt are currently in use in the United States. SHRP will develop improved asphalt binder specifications that will screen for properties more closely linked to pavement performance. SHRP's research plan starts with in-depth investigation of binder materials. Scientists at Western Research Institute at the University of Wyoming are applying sophisticated new techniques to investigate asphalt properties that may be related to adhesion, fatigue, aging, and other performance characteristics. Another high-tech approach to asphalt characterization is being pursued by SHRP under a joint project conducted by the National Institute of Standards and Technology with the University of Montana. They are using nuclear magnetic resonance spectroscopy to learn more about the chemical structure of asphalt materials and how composition changes under various conditions. By applying all of these state-of-the-art materials characterization techniques, SHRP is identifying and measuring the performance-related attributes of asphalt binders. The other key task is to determine how these attributes affect the performance of asphalt aggregate mixes. The University of California at Berkeley is exploring new, accelerated performance-related tests for prediction of the field performance of asphalt binders and mixes. Research dealing with the crucial asphalt aggregate interface is being conducted by the National Center for Asphalt Technology at Auburn University. The goal is to determine which fundamental interactions will create strong asphalt aggregate bonds. The Asphalt Institute conducted a survey of asphalt refiners in the United States and Canada for SHRP. Preliminary results show that virtually all the asphalts used in the United States and Canada are blended, and that the vacuum distillation process is used by about 2/3 of producers. To ensure the comparability of research results, SHRP maintains a materials reference library in Austin, Texas. 30 binders and 11 aggregates are stocked for distribution to researchers. Asphalt paving technology must adapt to continuing changes in the types of asphalt materials available in the U.S. market. By applying the most sophisticated techniques available to the analysis of asphalt materials, SHRP will enable industry to develop performance-oriented standards for the asphalt pavements of the future. Current pavement design practices are based on results of a road test that was completed more than 25 years ago. This road test was an accelerated field test of pavement performance conducted in a single location under uniform loading conditions. Trucks were driven around a test pavement and the resulting deterioration was measured. SHRP's long-term pavement performance, or LTPP program, is broadening and deepening available data on pavement performance by monitoring the condition of more than 1,000 pavement sections. The resulting data will help highway engineers tailor designs and maintenance treatments to specific conditions. All 50 states and the Canadian provinces are cooperating with SHRP by providing test sites, which are 500-foot-long sections of existing in-service highways. The highway agencies are providing SHRP with pavement design, construction, and maintenance records, as well as traffic data for each test section. SHRP conducts extensive core sampling to develop a detailed inventory of material characteristics at each site. SHRP has purchased 4 falling weight deflectometers to measure pavement strength at the test sites. Roughness is another important pavement characteristic. SHRP's pavement profile measurement devices, or profilometers, take periodic roughness measurements at the test sites. SHRP also takes continuous photographs of the test sections, using a camera mounted in the bottom of a moving vehicle. The photographs clearly reveal deterioration and make it possible to monitor the progress of pavement distress over time. The performance data will be stored along with the traffic and materials information in a permanent National Pavement Performance Database maintained by the National Research Council's Transportation Research Board. The pavement performance research will yield a wealth of useful information about the efficacy and relative cost efficiency of various construction, maintenance, and rehabilitation techniques. Analysis of the data will yield equations describing pavement deterioration rates that are applicable to pavement design and to highway management decision-making. The information obtained through SHRP's pavement performance research will give us the tools needed to extend pavement life, yielding better payback on funds spent on highway construction. Maintenance costs big money. Maintenance expenditures account for about 1/3 of total highway spending and have been growing at a rate of nearly 9% annually. It has become essential to find new ways to control maintenance costs. One way to squeeze the most out of every maintenance dollar is to select maintenance treatments that are well suited to specific pavement, traffic, and environmental conditions. Building on experimental designs developed by Texas A&M Research Foundation, SHRP will evaluate the performance of various pavement maintenance treatments on side-by-side test sections on in-service roads. The results of the performance evaluations will be used to develop criteria for selection of maintenance materials. Routine tasks like patching or sealing lend themselves to mechanization, but most maintenance work is still done manually, which is not only inefficient, but exposes workers to traffic hazards. SHRP is evaluating automated maintenance equipment and will determine what types of innovative equipment are most effective. SHRP also is addressing the important problem of worker safety. Highway maintenance is an extremely hazardous occupation, especially at temporary work sites without permanent safety barriers. SHRP is actively searching for innovative ways of protecting maintenance workers. Based on a design competition, SHRP will develop prototype devices and techniques to improve work zone safety. Examples of the products that might result include robotics to replace workers in hazardous positions, improved barrier devices, ways of speeding up maintenance operations to minimize worker exposure, and more effective methods of warning and communicating with drivers. Through SHRP, the latest technical know-how also is being applied to the age-old problem of the weather. The University of Wyoming is developing designs for innovative snowplows that will adapt to different kinds of snow and ice. When winter storms come, highway agencies need quick and accurate information about weather and road conditions to mobilize crews and equipment most effectively. Matrix Management Group of Seattle, Washington is developing integrated communication systems from existing components that will link weather services, highway maintenance managers, and road crews to provide nearly instantaneous coordination. Concrete is an extremely durable and strong building material. Cracks and potholes in pavements mean that somewhere along the line, something went wrong. SHRP is working hard to make concrete more foolproof and to fix what's wrong with the valuable concrete structures already in place. An investigation of cement and concrete microstructure underway at Pennsylvania State University will form the basis for many of the later products of SHRP's concrete research. Other contractors are focusing on specific performance concerns. Construction Technology Laboratories in Skokie, Illinois is investigating alkali silica reactivity problems, and the University of Washington in Seattle is studying freeze-thaw damage, including decracking. SHRP will develop improved tests and techniques for avoiding these problems in new construction and for correcting them in existing pavements. Non-destructive tests for condition assessment of both new and existing concrete will be a key product of SHRP's concrete research. Better bridge repair methods offer tremendous money-saving opportunity. Bridge repair will be the biggest bill for our highway system during the next decade. $20 billion worth of repair work needs to be done on corroded concrete bridges here in the United States. SHRP is developing some of the most promising new techniques for assessing and repairing corrosion damage, and is evaluating the cost-effectiveness of existing bridge repair methods as well. Cathodic protection systems have been used on highway bridges since the 1970s, but they need to be refined to encourage widespread use. SHRP will conduct field tests on state highway system bridges and develop cathodic protection application criteria for use by highway engineers. Battelle Columbus Laboratories began SHRP's cathodic protection work in 1988. At Virginia Polytechnic Institute in Blacksburg, researchers are evaluating more conventional bridge repair methods and will determine which are the most efficient under various circumstances. The final product of SHRP's concrete bridge research will be a manual for repair of reinforced concrete bridges suffering from salt-induced corrosion. The manual will provide a rational, cost-effective approach to bridge repair. Research progress is reported in SHRP's monthly newsletter, Focus, and findings will be published in special National Research Council reports, as well as through conferences, training manuals, and courses. As the results of SHRP's research become available in the early 1990s, state highway agencies will reap the payback from their investment of federal aid highway funds. State highway officials play an active role in administration of the SHRP program. Hundreds of state experts and others help to select SHRP contractors, to review research progress, and to test new ways of doing things. SHRP is helping highway agencies save money and develop better roads in the bargain by extending the useful life of new pavements and finding better ways to fix existing ones, by fixing our crumbling bridges and keeping us moving during winter storms. SHRP is paving the way for the roads of the future.